Good morning, guys, and let's get started on our last section in Chapter 10, 10.7, which is just called Special Segments in a Circle. So we're going to see a lot of calculations with segments. We don't really deal, too much in the beginning of this lesson with angles. So let's see where this is going to take us. Keep doing what you're doing. You're doing a great job. I'm so proud of you all. The next class period, of course, so you're going to do your lesson check. Then you'll have your homework assignment. After that, we're going to do a review on 10.3, 10.5, and 10.7, and then you'll have a quiz. Okay? So make sure you're just staying up on, all of the posts on Google Classroom. If you need anything, please reach out and let me know. Okay, so our first theorem, it got cut off a little bit, but you're not missing anything, is theorem 10.15, segments of chords theorem. And it's very wordy, so let's read it and then I'll clear it up. It says, if two chords intersect in a circle, then the products of the lengths of the chord segments are equal. So what does this mean? This basically, a lot of times I just refer to it as the crisscross theorem, because what I like to say is, when these when these segments intersect each other, they're cutting those segments into pieces. So two separate blue pieces in this case, and two separate orange pieces. So what you do is you're going to multiply the two pieces on the same segment and set them equal to the other two pieces of the other segment multiplied together. So a lot of times the way I refer to it is A times B equals C times D. So you're actually, the pieces you are multiplying is the same segment, okay? And you're setting them equal to the other pieces of the same segment. So A times B equals C times D. And you'll get used to seeing this theorem a little bit more once we practice with it. So let's do that. We are finding for both of these the value of X, okay? So let's look at the first one. So we're going to use the same segment. So we see segment AC is cut into pieces. So we're going to take the two pieces that are on the same segment and multiply them together. So 8 times X equals the other two pieces on the same segment, we're multiplying them together. 12 times 9. So it's actually the opposite of what you would think. You're multiplying the pieces on the same segment together. So you're going to get 8X is equal to 12 times 9 is 108. And then, so X will equal 13.5. Okay, so the pieces on the same segment are being multiplied together. So for the next one, what do we have? For the next one, we're going to take X and multiply it by X plus 10, because they're on the same segment. And set that equal to the other two pieces on the same segment, which are X plus 2 times X plus 4. Make sure you're using parentheses. Okay, now what are we going to have to do here? On the left side, we're simply distributing. So we'll get X squared plus 10X. X times X is X squared. And that's going to equal. On the right side, on the other hand, we're going to have to FOIL. Okay, so our first X times X is X squared. Our outer terms, X times 4 is 4X. Inner terms, plus 2X. Last terms, 2 times 4 is 8. Okay? Now, just like what happened in the last section, what's really nice here is you think you might have to get one side equal to 0 and factor, but you actually do not. We can cross out our X squareds. We get 10X is equal to, well, I don't like this color. I feel like you guys might not be able to see it, so let's switch it up a little bit. So we'll get 10X is equal to 4X plus 2X is 6X plus 8. Solve for X. 4X equals 8. X is going to equal 2. So the big thing here is making sure you're multiplying together the pieces on the same segment. Okay? Okay, again, guys, remember you can go to the you try problem. I say it every time. There are 2 you try problems you can try, and check your answers on my worked out solutions to make sure you understand them. Okay? Example 2. Let's talk about this one. It says, the true shape of a rainbow is a complete circle. However, we only see the arc of the circle that appears above the Earth's horizon. Now, I don't know about you guys, that's pretty awesome, especially if, we'll never be able to see the whole thing, but that is a really, really cool fact. But what we see is the arc that's above the Earth's horizon. What is the radius of the circle containing the arc of the rainbow shown? Okay, so here's the deal. I'm going to draw what we see. Okay, so we have the circle. We know they tell us that each of these pieces of the chords are congruent, so each piece is going to end up being 2.5 if the whole thing is 5. So we have our perpendicular in the middle, we have 2.5, we have 2.5, and then they also tell us that we know that this little piece up here is 0.7. Okay? They're saying, what is the radius of the circle containing the arc of the rainbow shown? So you cannot, there's no theorem here to just go find the radius. We don't know enough information. We can't do what we did in 10.3 or 10.5 and, draw a radius anywhere because we don't know enough. So my whole goal is, if I draw this circle, I know that this piece right here that's 0.7 will extend down across the circle. Okay? And if it's perpendicular at this point, if we think back to one of our last theorems in last section, if we have a perpendicular here, it has to be part of the diameter. So I know that my piece in green is part of the diameter. Okay? So if I can find the diameter, then I can divide it by 2 and find the radius. So that is my goal. So let's see. So what piece do I actually want to find then? I want to find this piece right here that I just marked as X and I highlighted it in red. How can I do that? Let's think back to our last theorem. We know that if we have a circle and two chords are going to intersect each other, doesn't matter if it's the diameter or not, that we can multiply the two pieces on the same segment times the two pieces on the same segment, and we will get our answer. So that's what we're going to do. 0.7 times X is equal to 2.5 times 2.5. We'll get 0.7X is equal to 6.25. X is equal to 8.93. So what does that mean? So that means this piece is 8.93. So how can we use that to find the diameter? Well, my diameter is going to be equal to 8.93 plus 0.7, which is 9.63. If my diameter is 9.63, how can I find my radius? Divide 9.63 by 2. So my radius is 4.81. And in this case, it's in miles. Sorry guys, this is 4.81 miles. If you think about it, it's a rainbow. That makes sense. Okay? So you're using the past theorem. I created a full circle. I have pretty much everything I needed besides our bottom piece that I just squiggled out in black. I found that using our previous theorem, added that to the 0.7 to find the diameter, then divided it by 2 to give me the radius. Okay? Good job there. Make sure if you need to, you watch that example again. We're going to go through another example just like it right now so that you can see another one. Okay. Our next example, similar to the last, says the highest point, or apex, of the Astrodome is 208 feet high. And that's huge if you think about it, 208 feet. And the diameter of the circle containing the arc is 710 feet. How long is the stadium from one side to the other? Okay, so the highest point of the Astrodome is 208 feet high. The diameter of the circle, so of course, if we were to draw an Astrodome in this case, it's not going to be a circle just sitting on the Earth, right? You're only going to show the portion that I just drew, right? You're just going to show this little, it's not a semicircle, but the little part of the circle. So the highest point is 208 feet tall. So if you measure from the ground to the top of the Astrodome, it's 208 feet. We know, though, that this came from a circle. So what they're saying is the circle containing that arc, let me redraw that so it's a little better. has a diameter of 710 feet. So if the diameter is 710 for the whole thing, but we know part of the diameter is 208, what I'm going to do is 710 minus 208. That will give me the height that would technically be below the ground for the rest of the circle. So 502. Okay. It then says how long is the stadium from one side to another. Well, the 208, the apex, is directly in the middle, so what we're really finding is each of those pieces, x and x, and we're going to add them together to get the full length from one side of the stadium to another. Remember, the part that is in red that I'm highlighting is the stadium. The rest is the circle that we would draw to, create the part of the stadium. So now from here, what are we going to do? We're going to use the previous theorem. So the pieces that are on the same segment, 208 and 502, get multiplied. And then we're going to multiply the x times the x because they're on the same segment. 208 times 502 is 104,416, and that's equal to x squared. I'm going to take my square root, and I get that x is 323.13. Sorry about that typo. So this means from the center to one side of the stadium, we're assuming the stadium is, the same from the center to both sides, is 323.13 feet. But we want the entire length across, so we're going to multiply that by 2 or double it, and we'll end up getting 323.13 times 2, because it's x plus x here, is going to tell me that the entire stadium is 646.27 feet across. And that is across the length of it, or from one side to the other. Okay? So definitely a little bit of challenging problems. There is a you try problem that you can go on and try to make sure if you understand that. Definitely some challenging problems because it's different to think about. But we're using that last theorem to help us. Good job so far. Let's keep going. We have a few more things to talk about. So theorem 10.16 says secant segments theorem. So this says if two secants intersect in the exterior of a circle, so secants specifically have to go intersect the circle twice, then the product of the measures of one secant segment and its external secant segment is equal to the product of the measures of the other secant and its external. So here's what I do here. Basically, if we look at the full segment, so let's look at AC, right? So we have AC, and then we have AB. This theorem says you take the part that is outside the circle, AB, and you're going to multiply it by the whole segment, AC. And you set that equal to the other part outside, so AD, times our whole segment, AE. So a shortcut for this theorem is outside times the whole segment equals the outer piece times the whole segment, which you can see below. Okay? Theorem 10.17 is pretty much the same thing. So we still have the outer piece and the whole thing. The only difference is if one of the pieces is tangent, you just multiply the tangent piece by itself. I like to say if the piece is tangent, the outer and the whole are the same thing. So outside times whole, and just multiply the same thing by itself. Okay? Which is why they get JK squared. It's really JK times JK. And then the outer JL times the whole thing. So outer times whole equals outer times whole. Okay? So let's do an example so you can see how to use this. So we know it's secants, so we're dealing with secants because they go through the circle twice, right? So whenever you see this, secants on the outside the circle, you're going to think outside times whole equals outside times whole. So I'm going to identify the outside piece first. So my outside piece is x. And then what is my whole segment? My whole segment, if the outside piece is x and the inside piece is 9, it's going to be x plus 9. So outer times whole is x times x plus 9 equals, for my bottom segment, my outer piece is 4. My whole piece is 4 plus 5, which is 9. So it'll be 4 times 9. Okay, so outer times whole, so x times x plus 9 equals 4 times, and I'm going to move this 9 so you guys don't get confused. The whole thing is 9. And then we're going to clean it up. Distribute. X times x is x squared plus 9x equals 4 times 9 is 36. Now here, the x squared doesn't cancel with anything. So you have to get one side equal to 0, move the 36 over, and factor. So we want factors of 36 that add, negative 36 that add to 9. So they multiply to negative 36, and they have to add to 9. And the ones that scream at me are positive 12 and negative 3. They multiply to negative 36, they add to positive 9. So it'll be x minus 12, x plus 12 times x minus 3 equals 0. So we're going to solve these. X equals negative 12, x equals 3. Can a side length be negative 12? Hopefully you'll tell me not. So our only answer is just going to be x equals 3. Okay? So outer times whole equals outer times whole. And we have one more segment to talk about, one more example. It's very similar. Go try the U problem for this problem, and then you want to look at your next example, which I may have, oh, I have it right here. Perfect. So example 5 says, segments that appear to be tangent are. So that means that LM is going to be tangent, okay? But JL is a secant. So let's look back at our theorem. We're most likely going to use theorem 10.17. Outside times whole equals outside times whole. So the only difference here is, let's start with the top. My outside piece is x. My whole piece is going to be x plus 2. So x plus x is 2x plus 2. So the whole thing is 2x plus 2. So outer times whole equals, now the bottom piece is tangent. So what did I say to do for this one? Well, if it's tangent, it's outer times whole. They're the same thing. So it's 12 times 12. The theorem says tangent squared, so it'll be 12 times 12 anyway. And now let's clean it up. So x times 2x is 2x squared. X times 2 is plus 2x equals 144. Okay, this one you have to do the same thing. You have to factor. But before we do that, what I want to ask you guys is, I'm a little step ahead of myself. Do you see anything that we could divide by to make our lives easier? Well, everything has a 2 or is divisible by 2. So divide everything by 2. You'll get x squared plus x equals 72. X squared plus x minus 72 equals 0. And now we're going to factor. It's a lot easier to factor when it's just 1x squared rather than a number in front. So we want two numbers that multiply to negative 72 and add to 1. And those two numbers are going to be 9 and 8. But for them to add to a positive 1, we need the 8 to be negative. So x plus 9 times x minus 8 equals 0. X is going to equal negative 9. You can't have a negative side length, so x equals negative 9 is going to go away. So that means x equals 8 is my answer. Okay? Outer times whole. I can't express enough. Out times whole equals outer times, stylus is acting up, whole. Okay, look back at those theorems. Again, you have examples in your notes to help you. You can try Khan Academy. You can ask me questions. I love helping you guys, and I miss helping you in person, but I will do the best I can to make sure you understand what's going on. Okay, just a reminder, complete your lesson check, and then the next period you'll complete your homework. And don't forget, after that you'll have a review and a quiz on 10.3, 10.5, and 10.7. Keep up the good work, and if you have any questions, make sure to ask me.